Hello everyone, my name is Ganesh Totla. I've been working with eTutions for a quite long now. So eTutions is an online platform where a student can be connected via a tutor. So online, obviously, for all the subjects. So it's a very wonderful platform. So if you want to explore it, the link for the website is given in the comment box for this video. If you also want to connect with me, my link, like the tutor link, is also mentioned in the below comment section. So please go through it and let us know. So in the last demo video, I've been talking about the limits. I've spoken about the basic fundamental limits. So I'll just quickly revise the formulae for limits, what we have seen in the last video, and then we will start solving problems today. So the very first limit we have seen in the last video was limit of x raised to n minus a raised to n divided by x minus a, where n is tending to, where x is tending to a, it is given as n into a raised to n minus 1. A corollary of this limit formula, we have seen that limit as x is tending to 1 of x raised to n minus 1 divided by x minus 1 is simply n. The third formula we have seen was for the limits of the standard trigonometric functions or the limits of the circular functions. So limit of sine of theta divided by theta as theta tends to 0 is always 1. So whatever the theta we have here, the same theta should be in the denominator. If it is not, we need to adjust this theta and find out the values. That we will be anyhow looking into the problems. Next one, we had limit as theta tends to 0 of tan theta upon theta is also equal to 1. And the last formula we have seen was limit as x is tending to 0 of 1 minus cos of x divided by x square. So whatever the x we have here, the square of that theta should be there in the denominator, and this is equal to half. So these were the standard limits what we have seen it in the last class, in the last demo. So in today's session, let's solve few problems on it. So let's divide the chapter of limits, not only limits, but all the calculus problems into different types. So type 1 will be the simplest problems. Type 2 will be the simple one, but harder than type 1 and so on. By categorizing the problems, it would be easier for us to solve them in the paper as well as in the practice sessions. Okay, so let's start with the type 1 problems. So type 1 problems means in limits, it is simple algebraic limit or simple algebraic functions. Let's start with simple algebraic functions. So let's consider the first problem. The first problem is limit as x is tending to 2 of x square minus 2x plus 3 divided by x square minus 1. Now, in order to solve the problems on limits, first we have to check whether we are getting any indeterminate form or no. Now, what do you understand by an indeterminate form? So, any function of the form either 0 by 0 or 0 raised to 0 is called as an indeterminate form. Indeterminate means it is something that we cannot find it. The value of that we cannot find it, hence it's called as indeterminate. So in order to take the limits, first we have to check whether we have 0 by 0 kind of indeterminate form or no. If we have it, then try to remove the factor from the denominator which is causing 0 in the denominator, because something upon 0 is infinity. We know that, but 0 upon 0 is itself not defined. So as I said, step number 1 is check if we are getting 0 by 0 after putting the limits. So just let's put the value of x as 2. So we get 2 square minus 2 into 2 plus 3 divided by 2 square minus 1. So 2 square is 4 minus 4 plus 3. Answer is 4 minus 1. So it will be 4 and 4 gets cancelled. So we have 3 upon 3. Answer is 1. So obviously we do not get 0 by 0 form. Therefore, there is no need to eliminate any factor, or there's no need to simplify the numerator and denominator. Straight away, we are going to take the limits because we are not getting 0 by 0 form. So we have just taken the limits here and we got the answer as 1. So if we get somehow 0 in the denominator, try to remove that factor from the denominator which is causing its value to be 0, because anything upon 0 is not determined. It's basically infinity for us. Okay, so I hope the first example is clear. Now let's solve the another example. Limit as x is tending to 2 of x square minus 4 divided by x minus 2. Now here, let's see and put the limits first and check if we are getting 0 by 0 form. So it will be 2 square minus 4 divided by 2 minus 2. So yes, we are getting 0 by 0. So in this case, we have to try eliminating the denominator because it's because of the denominator I'm getting 0 value. So how to eliminate that? Try to factorize the numerator. Try to express numerator in terms of denominator. If we do that, we can cancel off the common factor and get the solution. Okay. So I know that. So how can I write your denominator in terms of numerator? I know that the numerator is difference of 2 squares because 4, I can write it as 2 square. So x square minus 2 square divided by x minus 2. Either you can use the standard limit of x raised to n minus a raised to n divided by x minus a. You can do that way. Or you can simply use difference of 2 squares. I would personally recommend to use difference of 2 squares because that will be easy. So it will be limit as x is tending to 2. So difference of 2 squares is given as the product of the sum and difference of those two numbers. So x square minus 2 square I can write as x minus 2 into x plus 2 divided by x minus 2. This x minus 2 gets cancelled. So now we are just left with limit of x tending to 2 of x plus 2. Now we have to keep on factorizing the numerator and denominator till we do not get 0 by 0 form. Okay. Now here the denominator itself is 1 now. So obviously we are not getting 0 by 0 form. So what we will do is we'll simply take the limits. So just put the value of x as 2. So it will be 2 plus 2. Answer is 4. So the limit of this particular function when x is tending to 2 is 4. I hope this problem is understood. It's simple. It's nothing that complicated. Okay. Now, next problem is, let's solve the third problem. Question number 3. Limit as x is tending to a of x raised to 5 minus a raised to 5 divided by x cube minus a cube. Now, the given, let's take again, if which we are getting 0 by 0 form. So it will be a raised to 5 minus a raised to 5 divided by a cube minus a cube. So we get 0 by 0. Yes, we are getting indeterminate form. So now, how to solve this problem? So just recall that we have seen now one standard formula for limits we have seen. And what is that? X raised to n minus a raised to n divided by x minus a is equal to n into a raised to n minus 1. But for that, to use this formula, x raised to n minus a raised to n upon x minus a, as x is tending to a, we need the denominator as x minus a, correct? But here, the denominator is x cube minus a cube. So what we will do is, we will try to get the denominator as x minus a. So how are we going to do is, it's very simple. We want x minus a in the denominator. So what we will do is, divide both numerator and denominator by x minus a. So if I divide it by x minus a to both numerator and denominator, I'll get the problem as x raised to 5 minus a raised to 5 divided by x minus a divided by x cube minus a cube divided by x minus a. Now, we have seen the theorems on limits. limit of f of x upon g of x is equal to limit of f of x divided by limit of g of x. So just split this limit. So we will be having limit as x is tending to a, x raised to 5 minus a raised to 5 divided by x minus a divided by limit as x is tending to a, x cube minus a cube divided by x minus a. Now we can take the individual limits. So this limit is n, that is 5 over here, a raised to n minus 1. So it will be 5 minus 1. So it will be 3a raised to 3 minus 1. So it will be 5a to the power 4 divided by 3a to the power 2. So a square and 4 gets cancelled. So we simply have 5 by 3a square. So the limit of this function, x to the power 5 minus a to the power 5 divided by x cube minus a cube, it is equal to 3 to the power of a raised to 2. I hope this question is clear. It's straightforward, just we have used the formula, but this problem, it does not involve the usage of formula directly. We are using this formula indirectly by doing some adjustments. And what is this adjustment? So we are just dividing both numerator and denominator by x minus a. I hope this problem is clear. Now, let's solve the another example. So, the example is as below. Limit as x is tending to 2 of x into root x minus 2 root 2 divided by x square minus 6x plus 8. Now let's check if we are getting 0 by 0 form first. Then only we have to factorize, else there's no point in factorizing this. So it will be 2 root 2 minus 2 root 2 divided by 4 minus 12 plus 8. And yes, we are getting 0 by 0. So this is indeterminate form. So let's try to simplify. Now, x root x minus 2 root 2. So whenever in numerator we get root x and x associated, or 2 and root 2, or n and root n associated, always try to use this formula. X raised to n minus a raised to n divided by x minus a, limit as x is tending to a is equal to n into a raised to n minus 1. Now, how to convert numerator in that form? This numerator is not in the standard form. So, what we will do is, x, I'll keep it as it is. So, limit as x is tending to 2 of x as it is. X, I can write it as x to the power of 1. Root x, I can write it as x to the power of half. Yes. Minus. This 2 root 2 also I can write it in the same way. 2 raised to 1, 2 raised to half divided by. Now, x square minus 6x plus 8. You have to factorize it. How can you factorize? We need two factors of 8 such that the product is 8 and the sum is negative 6. So obviously these factors are x minus 4 and x minus 2. Yes. So this I can write it as x minus 4 into x minus 2. Okay. I hope this is clear. Now, next, limit as x is tending to 2. X raised to a, like x raised to a, or use law of indices here. A raised to m into a raised to n is equal to a raised to m plus n. Here the base x is same. So it will be x raised to 1 plus half minus 2 raised to 1 plus half divided by x minus 4 into x minus 2. So this will be limit as x is tending to 2. It will be x raised to 3 by 2 minus 2 raised to 3 by 2 divided by x minus 2 into x minus 4. To use this formula, x raised to n minus a raised to n upon x minus a, I'll apply the limits formula for this. Yes. So what I'll do is limit as x is tending to 2, 1 upon x minus 4, I can write it down as it is, into limit as x is tending to 2 of x raised to 3 by 2 minus 2 raised to 3 by 2 divided by x minus 2. Here you can take the limit value as it is because it's not of the form of 0 by 0. So it will be 1 upon 2 minus 4 into. Now, limit of x tending to a of this is nothing but n into a. A's value is 2. So 3 by 2 into 2 raised to n minus 1. So it will be 1 upon minus 2 into 3 by 2 into 2 raised to 3 by 2 minus 1 is half. So I get minus 3 by 4 to half, like 2 raised to half. So what I can do is 3 by 4, again, negative 3 by 4, I can write it as 2 square. And this 2 raised to half, I'll keep it as it is. So it is 2 raised to half. So this is negative 3 into 2 raised to half minus 2. So answer is negative 3 into 2 raised to 1 minus 4. So it will be minus 3 by 2. So the answer is this for that limit. So I hope this question was a bit tricky, but if we know the concept, if we know how to use the formula, if we know how to do the adjustments, then we would be able to solve such type of problems. I hope this problem is clear. Now let's solve one more problem. Yeah, let's solve one more problem. Limit as x is tending to 3 of root of 2x plus 3 minus root of 4x minus 3 divided by x square minus 9. Though the problem looks complicated, it is not. Why? Always keep this in mind. This is a thumb rule. If there are difference of roots or if there is any root either present in numerator or denominator, go with rationalizing that part. Now, what do you understand by rationalizing? Rationalizing means multiply and divide by the conjugate of either the numerator or denominator. Now, what do you understand by conjugate? Suppose if I have root of a plus root of b in the numerator. When I have to rationalize it, that means I'm going to multiply by the conjugate of it. So conjugate of this is just change the sign. And that will be its conjugate. So root a plus root b, if we have, just take the conjugate of that will be root a minus root b. Just change the sign. If it's negative, it will be positive. Just change the sign. So just rationalize this. Rationalize this means we are going to multiply and divide by the conjugate of the numerator. So what is the conjugate of the numerator we get? So limit as x is tending to 3, root of 2x plus 3 minus root of 4x minus 3 upon x square minus 9. I'm multiplying and dividing by conjugate. So conjugate will be just add plus sign over here. That will be the conjugate. So it will be root of 2x plus 3 plus root of 4x minus 3. Now, as we are multiplying by conjugate, naturally, we have also to divide by the conjugate because we don't want to change the value of the given function. So it will be root of 2x plus 3 plus root of 4x minus 3. So this will be, now limit as x is tending to 3. In numerator, we can see that it is of the form a minus b into a plus b. So obviously this is difference of two squares. So it will be a square minus b square. So it will be root of 2x plus 3 the whole square minus root of 4x minus 3 the whole square. Now this square, this root gets cancelled. This square, this root gets cancelled. Divided by, we have x square minus 9 into root of 2x plus 3 plus root of 4x minus 3. Now, so this will be limit as x is tending to 3. So it will become 2x plus 3. Just open out the bracket. So it will be minus 4x. Minus minus gets converted to plus. So it will become plus 3. This will be x square minus 9. X square minus 9, I can write it as x plus 3 into bracket x minus 3. Again, it can be written as difference of the square. Yes. And multiplied by root of 2x plus 3 plus root of 4x minus 3. So this will be limit as x is tending to 3. 2x minus 4x is minus 2x. Plus 3 becomes plus 6 divided by x plus 3 into bracket x minus 3 and the root as it is. So it will be root of 2x plus 3 plus root of 4x minus 3. Now from the numerator, so obviously again I'm getting still 0 by 0. That means where I'm getting 0 in denominator, when I put x is equal to 3, it's because of this factor I'm getting denominator as 0. So I'll try to eliminate this factor. How? From the numerator, I can see that I can take minus 2 as common. So it will be x minus 3 divided by x plus 3 into x minus 3 into root of 2x plus 3 plus root of 4x minus 3 as it is. Now this minus 3, x minus 3 gets cancelled. So, and then take the limits because obviously the factor which was causing denominator to be 0 is now eliminated. So take the limits. So we will be having negative 2 upon 3 plus 3 into root of 2 into bracket 3 plus 3 plus root of 4 into bracket 3 minus 3. So it will be minus 2 upon 3 plus 3 is 6 multiplied by 2 into 3 is 6. 6 plus 3 is 9. So root of 9 is 3 plus again this is 9, this is 3. So it will be negative 2 upon 6 into 6. So 2 ones are 2 threes are. So answer is negative 1 by 18. So the limit of this function is negative 1 by 18. Looking at the question seems difficult. But if we use the technique of rationalization, you can get this answer quickly. Rationalization means multiply and divide by the conjugate of either the numerator or denominator. That depends upon where the root signs are. So whenever there is a root sign either in numerator or denominator, we go for rationalization. Hope this problem is clear. So these were the problems on type 1. In the next video, we will solve the problems on type 2. That will be trigonometric limits. So I hope the problems what I have solved today is clear to you. If you have any doubts, you can mention your doubts in the comment section. If you want to continue with me as a tutor on eTutions, my link is given in the description. You can use it. You can visit that link. You can visit the website and then do let us know. Thank you all for your time. See you in the next video.